So today we would start a tutorial series on CERN root. In this first lecture I will not go into technical details or installation. Instead we will focus on a clear understanding of what root actually is, why it was developed and what makes it so important. So the question, what is root? Root is a scientific software framework created at CERN, Geneva, which is a known research center. It was developed in 90s to solve one big challenge, that how to analyze the enormous amount of data produced by particle physics experiments like at the Large Hadron Collider. Billions of collision happens, and each collision produces data about particles, their energy and momentum, and many other such properties. So analyzing this data requires very powerful tools, and root was the answer for that. Root is basically written in C++, and has a huge collection of libraries and tools. But what makes it special, that it combines different tasks in one framework. Like for example, with root you can store and organize large datasets, visualize data through histograms, graphs and even three-dimensional plots. You can perform statistical analysis and fit mathematical models to your data. You can write and run scripts in C++, or even you can write in Python, and you can automate these scripts to run your analysis. And finally, produce publication quality plots and figures that scientists can use in their paper. So why do physicists use root instead of other tools? This is also a question. And the main reason, actually there are many reasons, one of them is that root is free source, but the main reason which I think is the scale. Imagine trying to analyze millions or even billions of events with regular tools like Excel or Origin or even standard Python libraries. It would be far too slow. Firstly, it would be slow, and also it would be inefficient. We need the right tool for the right job, and root is that tool which can do this job very efficiently. So root is optimized for scientific data analysis at large scale, which makes it essential for experiments at CERN and other big research labs. Actually, it is not limited to physics alone. It can be used in astronomy, biology, and even it is used in finance. To be honest, I don't know that what sort of applications they excels from the root, but basically in the field where people need to process and analyze complex data sets, root is the right framework. To give an idea of what root can do, let me describe a very simple example. Suppose you have a data set of particle energies. With root you can create a histogram which shows how these energies are distributed. You can then fit a curve to that histogram like a Gaussian, to extract parameters such as the mean and the standard deviation, and what just a few lines of code. So root will generate a professional quality plot with just a few lines of script. In this first lecture, the main point I want you to take away is that root is more than just a plotting tool. It is a complete, I would say, ecosystem for scientific data analysis. Not just analysis, but for combining storage, computation, statistics, and visualization into one unified framework. That is why it is the standard tool used in physics around the world. In the next lecture or a couple of lectures, I will guide you through installing root on your computer and make sure it set up correctly. Basically, I'm using on my Linux slash I am using the Ubuntu version of the Linux. It can also be installed on Windows, but to be honest, I didn't have jumped into that and didn't know how to do that. So if you are using Windows, you can check other tutorials on that, how to install it on Windows. But once it is installed, it works the same in either you are using it on Windows or Linux or Mac. It doesn't feel any difference then. So after that, we will begin using root step by step, starting with simple commands and moving toward more advanced analysis. So for now, just remember that root is the foundation of modern data analysis in high energy physics and particle physics. And in this series, we are going to learn how to use it from the ground up. Thank you.